All right, all right, all right. This is Mr. Crawford, and I'm very excited to talk about discounts and markups. Understand when you go to a store, you go in, you think, oh, snap, I'm about to pay like $20 for this pair of headphones just to get some headphones. Then you go to the register, and then it's like $21.20. Like, where'd that come from? Or sometimes your mom may go to a store and she said, "Ooh, a 40% discount." So let's say she buy her favorite blouse that's like $40, and she get a 40% discount, and then she paying $24, and she's thanking Jesus for the fact that she saved her $16. I'm going to show you a couple of problems that will explain why you get those amounts that I mentioned a few minutes ago, really a few seconds ago. All right. First of all, whenever you do work where you have to type, if I do not give you a Google document, you can do the following: type doc.new. And before you get started with anything, please, please, please make sure before you even share it with me that you type your last name. I'm typing Crawford because Crawford is my last name. And then you type today's date. That makes it easier for me to keep record. All right. So let's get started. These problems that I'm going to take will be two problems that I'm taking from the textbook, and I'm going to break it down bit by bit by bit by bit in order to make it understandable. Please make sure you slow down and pay full attention to what I have to say and all the details. And then, two, do not be surprised if you have to watch the video again. That's okay. That's normal. Remember, when you're learning something new, it's tough. Okay, young people. I thought I was going to do two problems, but I looked into the textbook and I saw five because there are a lot of concepts that I could go over. And this gives me an opportunity to take you back to the fourth or fifth grade. So I was like, I love this. So let's get started with number one. As you see, I have already typed up everything that I needed to do the problems, but I'm going to have to make some changes as I type the answers because this is going to be something that I expect of you. The good thing is you won't be assigned as many word problems as this. I will probably assign three per week, maybe even four, but I may not give you as many problems with this level of rigor, especially the rigor of number three. Like if I give you a problem like number three, more of your problems will be easier. But if I give you problems like number one, two, four, and five, since those are pretty easy, you will see more of those. Okay, let's look at number one. A pool manager balances the pH level of a pool. The price of a bucket of chlorine tablets is $90, and the price of a pH test kit is $11. The manager uses a coupon that applies a 40% discount to the total cost of the two items. How much money does the pool manager pay for each item? First of all, with this problem, we have levels of confusion. I can see anybody doing this problem and thinking, oh my God, too much is going on. So let's talk about it. pH level. When you see this, this will throw you off. And that's what it's meant to do. It's meant to throw you off and knock off your focus. But it is your job as a person who's reading and solving a problem to make sure you understand what you need and what you don't need. And the best way you're going to find out what you need and don't need is mostly going to be at the end of the problem when you are given the instruction. The question is, how much money does the pool manager pay for each item? The question is, what are the two items? So we have a bucket of chlorine tablets. That is clearly a noun. Since that's a noun, we can look at that as an item. And then we have the pH test kit. That's clearly a noun, which is a person, place, a thing, which is another item. So the best way we could do this before I do any math, I want to give you a formula. And I'm going to do this in blue. I'm going to go to my trusty insert equation and make it look fancy. Okay. So what we want to know is the new price. I'm going to call that P. And then I'm going to say that P is equal to the original times 1 minus D. And I'm going to call that discount. And what I realized I needed to do is write it in word form. I'm going to write this formula out in plain English. New, oops, and let me keep this in blue. Let's keep the blue thing going on. New price equals original price times 1 minus the discount in decimal form. This is what this formula means. So, what we need are our original prices. And let's go ahead and let me underline this part right here for consistency's sake. So we need original price, and we have two of them. I'm going to mark the original price in orange. That might be too bright. In dark orange, those are our original prices and our discount. These can help us find exactly what we need. So let's go ahead and make use of our equation. One thing about me is I like shortcuts, but before I go ahead and do a shortcut, let's do something about that 40%. One thing I said is that the discount has to be in decimal form. So when you hear like 40% discount or you hear like 40% off, that's the same thing. So what I will do is take the 40% and put it in decimal form. Since 40 is a two-digit number, to put it in decimal form, I can literally put 0.40. That's it. And that only works with two-digit numbers. So we got that. And we have what we need. So let's go ahead and make use of our formulas. One thing I do not like to do is the same thing twice. And I'm going to show you exactly what I mean. Let's put this in gold. So we have bucket. You know what? That works so much better in my head. We're going to do dark purple. Bucket of chlorine. That's going to be the price. And what we're going to do is put the original, which was 90. And, oops. You know what? I realized I wanted to get a bit more fancy with this. So I'm going to copy this and paste it. Oops. So I'm going to change this P to dollar bucket of chlorine for its original price and put the discount. And let me see if I can change this color inside. No, this is being a meanie. That's okay. Now, what I'm going to do is do another copy and paste. And the reason why I'm doing another copy and paste is simply because I don't want to rewrite zero point 0.4 since I know I'm going to use that again. I know the second item costs $11. pH test kit. That's going to be equal to 90. 1 minus zero point 0.4. It's kind of like 10 minus 4, which is 6, but a slight difference. It's going to be zero point 0.6. And and I have a little trick with this, since 90 has one zero and zero point 0.6 have one zero, it's pretty much the same thing as multiplying 9 times 6. It's the same thing as multiplying 9 times 6. Since 90 is a tens and zero point 0.6 is a tenth, that 10 and that tenth, they cancel out, leaving us nothing, leaving us only with the 9 and the 6. So I got 9 times 6, which is 54. That's a nice little shortcut I like to use. I'm going to do the same thing with this one. I have 11, and again, 1 minus zero point 0.4 is similar to 10 minus 4. Since I know 10 minus 4 is 6, I know that 1 minus zero point 0.4 has to be zero point 0.6. Now, with this one, this gets a little bit more interesting. I know that 11 times 6 is 66. Since I have a tenth of a 6, the answer is going to be a tenth of 66, which is simply 6.6. A tenth of a two-digit number is pretty much a decimal in between the two numbers. That's exactly what it is. And that is our answer for this problem. We have two answers for this problem. And that's it. Since I used copy and paste, it gave me a hard time with changing the colors. I may try to change the color, but I'm not going to waste your time doing this. Understand, the main focus is to answer the question posed to you. You are going to be given a lot of information in a problem that do not match the question that you are supposed to ask. It is your duty as a student to figure out what is asked. It is your duty to ask me if you're not understanding what's going on. And that's a good thing that I like about my class is that I'm going to help you become very good at reading because I'm an avid reader. What is so funny is as soon as I did what I had to do, I managed to change the colors. And I'm going to show you how to do that while doing this problem. So, number two, you buy a bicycle helmet for $22.26, which includes a 6% sales tax. The helmet is discounted 30% off the original price. What is the original price? The good thing about doing a previous problem is you could take from that to do a new problem. So you see this problem where I say, and I'm going to take both of these from the first problem. Copy and paste. New price is equal to original price times 1 minus the discount in decimal form. But I'm going to do a slight expansion of this formula. Not only do we have a discount, but we also have a tax times 1 plus the tax in decimal form. So in this situation, whenever you have discount, you subtract. Whenever you have tax, you add. And once you get used to this, then it'll come more naturally to you. And on the probably number three, I'm going to skip some steps just to show you how it would look when you're more comfortable. All right. So all we have to do in this problem is plug in everything. Before we plug in, let's make use of our numbers. What I'm going to do is mark the original price in red. Then I'm going to mark the sale tax in this type of blue. And then finally, I'm going to mark the discount in another color. Let's say super dark orange. And this is what I'm going to do. The price is a price. It's a decimal form, so I don't need to do nothing. And that's the goal of this type of problem. Keep everything as a decimal. Now, let's say we got 6%. 6%. The good thing about one digit percent is I can put zero point 0.0 and then the 6. And that's because when I do 6%, I have 6 divided by 100, or I have a single digit number divided by 100. And since 100 has two zeros, the decimal form has to have two zeros. All because 100 have two zeros, and you just put a zero between the first two zeros. That's it. Now I have 30%, and I'm going to put this as super dark orange. Super dark orange. And there you go. That's it. Again, we're looking for the good thing about using formulas is we look for consistency. We want everything to be the same. Since the price is a decimal, we want the percentages to be a decimal. Now I'm gonna use my formulas again. So we don't know the original price. We only know the new price. Put that in there. We know the discount, 0.3, which is the same as 0.30. And we know the rate, which is 0.06. All right, that's what we have. So we're going to simplify. This is simplify. I can't do nothing else with 22.26. I have to leave it alone. Now, with this 1 minus 0.3, it's similar to 10 minus 3. 10 minus 3 is 7. Since I have this 1 minus 0.3, I'm going to have 0.7. Now, I have 1 plus 0.06. All I have to do is this whenever I have this situation. That's it. Take out that extra zero, take out the plus sign. Take out that plus sign and that extra zero, and I'm fine. And finally, I want to solve for O. And what I'm going to do is move the 0.07 on the other side. The 0.07 and the 1.06, I'm going to move it on the other side with the 22.26. You know what? I'm just going to start fresh. And since I'm dealing with a fraction, I'm going to make this text a bit bigger. There you go. Now, what I'm going to do is the following. Before I get started, I'm going to put this right here as a placeholder. Before I get started, I'm going to change the order for simplicity's sake of this. The good thing about an equal sign is I can literally change the problem around based on where the equal sign is located. I can do that because both sides are equal. Now, what I'm going to have is O for original price. That's my variable. Then I'm going to create a fraction. So what's going to happen in a calculator? This is what it's going to look like. This is the order you're going to press the keys in order to do it in a calculator. You're going to type in 22.26 divided by 0.7 divided by 1.06. And after you do that, you're going to get 30. But let me insert a little bit more on why you do that. Whenever you have a fraction, you're dividing. And when you have two numbers or more numbers on the denominator, which is the bottom part of the fraction, that just tells you that each of those numbers are going to be divided into the numerator. Since I had 22.6 over 0.7 times 1.06, I can literally say in the calculator 22.26 divided by 0.7 divided by 1.06. And some people are different in their mathematics. If you wanted to, as well, what you could have did was have 0.7 times 1.06. You could have also done that, which before I'm thinking is I'll calculate that because I don't know that by heart. I have a guess, but I'm hoping my guess is correct. Oh, it was correct. So I could have did 0.7 times 1.06 and had 22.26 divided by 0.742, which is the same thing as what I did. But I chose to write it out like this because this is simpler. And it's easier for me to reference back to my fraction if I do it this way. So there's multiple ways to do it, but I chose the way I chose. Good luck. I found this problem to be very interesting because it gives you the backwards version of of working with discounts and markups. It gives you markups or taxes. It gives you the backup version, the backwards version, where you will see two different prices and you will have to find the discount to the nearest percent. And before you can do that, I have to give you a formula that you're going to use throughout this journey. And I have to make this bigger because of the fact that, yep. Yeah, I have to make this bigger in order to work with the fraction. This is called the percent change. And I want to give this some color. I'm gonna put it red because it's gonna make y'all mad. And the thing is, there's always a syntax order. I'm gonna put this dark red. Oh, so this is when those arrow keys come in. And I'm gonna be more general. So the quantities are the amounts. In this case, it'll be the difference in prices. All right. So for instance, with part A, in order to do part A, I need the difference in the prices. So we want to find what is the percent discount. Since we have a $10 discount, I'm gonna try to go for this again. Since we have a $10 discount, our difference is going to be 10. So between the prices of the same jeans, it went from 39.99 to 29.99, and the problem explicitly stated that there is a $10 discount. So I'm gonna mark this in orange because I need this. And also, if you're more comfortable with doing 39.99 minus 29.99 to get 10, that works as well. And the original price was 39.99. So one thing I did forget is to put this. I usually do the dot for multiplication since you guys are in middle school. And then two, I know when you get in high school, this X, even though you look at it as multiplication, but when you get older or if you take classes that I like to teach like physics, that X is really cross product. That means when you multiply two vectors, you get another vector. Yeah, I could go there if I want to. So let's just use a dot in middle school. Okay? Just use a dot. Or I'm going to teach you cross product if you use that X. So with that being said, since 39.99 is basically $40, it's like having 10 divided by 40 times 100. So when you get a calculator, you can do 10, and I will do the times first because of order of operation. 10 times 100 divided by 40. Go in that order when you put it in a calculator. And what you're going to get in this case is 25. So that's your answer for part A. And I'm going to change the color to gray. That's your answer. Now they want us to find the percent sales tax. Again, I can use the same formula. And what I'm going to do is copy and paste because I'm not going to kill myself to do no math problem. Again, the difference. The difference that we want is the 31.94 minus the 29.99. And that difference between them is 1.95 because that's the sales tax. The sales tax is the difference. And the original before I get the sales tax was 29.99. Now with this is where my showing off kind of stops. And what I want to do is be consistent with what the problem have has. Yeah, I want to be consistent with what the problem has. Besides putting it as 40, I'm gonna leave it at 39.99. So to avoid like where that came from. And again, what I did was I moved this out my way. Now this answer is going to be slightly different. When I put in my calculator, where I do 1.95 times 100 divided by 29.99 in my nice little calculator, I get 0. I get 6.502. All I needed was one number after the decimal, and I'm going to be more happy to go over rounding. So I definitely want to redo a lesson because I'm going to be very heavy about rounding. I'm not going to accept answers with a 2% error. I want you to round and show off that skill because that is something that should have been taught to you, but I don't mind reviewing it. Okay. Now, this one, part C. This is one of those examples where they would write a problem one way, but mean something completely different. So you have two things going on. That they say the price of the jeans includes the 60% markup. After the discount, what is the percent of markup to the nearest percent? So this is what's going on. That 39.99 was not always 39.99. It was cheaper. The original price of that jean before you got ripped off was the following. Now we got to go back to our original formulas from back here. And since we don't have discount, we could just take out this part of the formula. So let's go ahead and find the original price. Let's work with that part first. Let's work with this 60% markup. And since I talked about it, I'm going to go ahead and just kind of shortcut it. And my nice little trick whenever you add one to a decimal, just simply take out the zero and the plus sign. That's it. Because 1 plus 0.60, it's like adding 10 to point 0.6. I mean, adding 10 to 6, which gets you 16. And the reason why I can say that because the difference between 10 plus 6 and 1.1 plus 0.6 is that to get from 10 plus 6 to 1.0.6, you divide by 10. So 10 divided by 10 is 1. 6 divided by 10 is 0.6. Now, what I'm going to do is switch the equation around. Now I'm gonna go ahead and divide. And I switch it around because that's a property of an equation. I could just literally switch around both sides of the equal sign and get the same thing. So now I have O, capital O. Then I'm gonna set it equal to this fraction. Since I have the 39.99 to the right, I'm gonna keep it to the top. And think about with directions. Normally, when things move to the right or move up, that's associated with things that are positive. And when things move to the left or go down, that's associated with things that are negative. So when I do this and I calculate, I'm going to get about 24.99. So that's the first part of the answer. Now, let's go to the second part. And we're going to bring back our friend. This time, we're not given the difference in quantities. We're not. So we're going to have to do something a little bit different. Subtract explicitly. After the discount, we have 29.99 minus 24.99. The original price is the price after the discount because we're comparing. What we're comparing is the original price to the discounted price. The original price before they made the jeans more expensive, which was the 24.99, to the discounted price, which is the 29.99. So we know that 29 minus 24 is 5. And we know that 99 minus 99, and I'm separating it by the decimal, is 0. So we can have 5 here. And then we'll have 5 times 100. Oops, I don't want to put this, I want to put this times. Divided by 29.99. And that is going to be equal to, in the nearest percent, that is going to be equal to, I believe, 30%. Let me double check. Oh, it was 20%. My bad. Now allow me to make some changes. There you go. Doing some formatting. And let me take this out and put a regular division symbol to show you how it would look like in the calculator. The good thing is you don't have to do this when you're solving. I'm just showing you how it would look like in the calculator in order to teach you what to do. Okay. There you go. It's about 20%, and that's how you do number three. All right, number four, we got a drone that costs $129.50, and it is discounted at $40, 40%. Next month, the sale price is discounted an additional 60%. The question that rise is this drone free? If so, please explain. If not, find the sale price. And why I chose this problem to do to demonstrate is because I remember when I was younger, when I was your age, I would be like, you discounting 40% and you discounting another 60%? That's free. I don't know why they gave it this problem. I would get about 80. And then my teacher would turn around and be like, well, my answer book does not agree with you. And then I would start arguing, sitting there looking like a plumb fool. I would. I really would sit there arguing, looking like a hot mess, looking crazy, and then that teacher ain't paying me no attention. My teacher looking at me like my answer book said what it said. And I'm going to show you why the teacher's answer book will say what it say. Just because something has been discounted 40%, understand that the 129.50 is discounted at 40%. And then that new price that I get after I get that 40% discount will be discounted by 60%. You know? So that's what's happening. In other words, we're going to be using this formula. But I'm going to make a couple of changes. I'm going to call this discount one. Then I'm going to call this discount two. That's what that is. So let's go ahead and make use of this. Our discount one is 40%, 0.4, 40. Our discount two, 0.60. And our original price is 129.50. You know what? I don't feel like doing all that work. So I'm just going to copy and paste. 1 minus 0.40 is the same, is similar to 10 minus 4. The only difference between those two is I divided 10 and 4 by 10. Since I know that 10 minus 4 is 6, I'm just going to change this 4 to 6. Oops. Since I know that 10 minus 6 is 4, I'm just going to change this to a 4. Or what I could have did was got rid of the ones and just multiply because multiplication is commutative. That means no matter what order I multiply by, I'm going to get the same thing. And while I'm working on this problem, I'm going to show you another reason why this answer is going to be the way it is. I know that 6.4, 6 times 4 is 24. So 0.6 times 0.4 consequentially 0.6 times 0.4 is 0 times 0.24. So let me multiply the 0.6 times the 0.4, I get 0.24. And then I'm going to multiply that by 129.50 and get this answer that I got from the calculator. Because I'm not that good at math. I'm good, but not that good. And this is my final answer for 200. And there you go. Those are the four problems I demonstrated to you. As you saw earlier, there were five, but then I realized that I repeated a problem twice, trying to be hard and crazy. But one thing I do want to add before I leave this, notice whenever I'm doing prices or discounts, what I will always have is the original price multiplied by the discount. Let's say if I wanted to add a tax towards these two discounts, then I'm going to be multiplying three times. It depends on what I have going on. If I have a discount and a tax, multiply twice. I can have five discounts and one tax. I'm multiplying six times. It depends on how many times I'm discounting, is how many times I'm multiplying. How many times I'm discounting or adding a tax is how many times I will multiply that to the original price. So let's make sure we get that and understand that last part. That last part of what I just said is more important because it's a concept. These concepts will make it easier for you to solve problems that may look hard. And of course, right now it looks pretty hard because one, you're seeing it for the first time. Two, I'm over here typing it. And three, you're learning. It's part of the journey. My advice for you guys is to look at the problems that I did, switch the numbers around, and let's see what you can get. That's what it's called real practice. Go through the process as I went through the process. And you're going to be fine. If you get stuck, that's what I'm here for. Ask me some questions.